Today we are diving into something that's becoming super important if you're working with AI, search, or even just organizing information, and that is vector databases. Why you should care about vector databases at all? Well, the way we traditionally store and search information, like rows in a table or keywords in a document, doesn't work very well when it comes to more complex fuzzy or semantic data. Imagine trying to find similar images, documents with the same meaning but different words, or answer to questions that aren't word for word from a source. That's where vector databases come in. They store information in a way that captures meaning, not just exact matches. If you're getting into AI, retrieval augmented generation RAG, or building a smarter application, learning how vector databases work and how to build one is a must. Now, what is the vector database is? Instead of thinking about data as just text or numbers, think of it as points in a huge space. Each point represents the meaning of something, like a paragraph, a photo, or a sentence. Similar things are close together. A vector database is a special kind of database that lets you store, search, and retrieve these meaning points quickly and efficiently. Here's the plan for this video. I'm going to show you how you can take a simple PDF file, turn its content into vectors, and store them inside the vector database, all without writing complicated code. We'll use a tool called LangFlow, which makes the whole process super visual and beginner-friendly. By the end, you will know the basic steps needed to go from a document to a searchable, meaningful database, and you will understand the whole flow behind it. Let's get started. Let's get started with the concept of vectorization. When we design any retrieval system, one of the first key design decisions we face is how to prepare our external knowledge for retrieval. This is where the process of vectorization comes into play. Let's walk through the flow step by step. It all starts with the source data. This could be documents, websites, PDFs, internal reports, basically any external knowledge that we want our AI system to have access to. But the raw data usually isn't in a format that is easy to work with. It could be messy, structured in strange ways, or mixed with the irrelevant information. The first step is extract text. We need to pull out the actual text content from whatever format the source data is in. If it's a PDF, we extract the readable text. If it's HTML, we strip away the code and capture the visible text. If it's a database, we might pull a specific fields. The goal here is to isolate the meaningful content we want the AI to eventually retrieve and use. Next comes chunking the text. This is the crucial design step that often gets overlooked. Instead of embedding entire documents as one giant block, we break the text into smaller pieces called chunks. Each chunk might be a paragraph, a few sentences, or a logical section of the text. But why we do chunking? Chunking improves the granularity and precision of retrieval later. If we only embed entire documents, the search result could be too broad. By chunking, we create smaller, targeted units of meaning. This way, when the system later retrieves information, it pulls out the most relevant chunk, not an entire irrelevant document. Chunking also makes retrieval faster and more accurate because embeddings work best when representing focused ideas, not sprawling topics. Okay, we learned about chunking. Now we know that good chunking strategy is an art in itself. If chunks are too small, they lose context. If they are too large, they dilute the relevance. After chunking, we move to embedding. This is where the magic happens. We take each chunk and pass it through an embedding model. Embedding model transforms the text into a vector, a list of numbers that mathematically captures the meaning of chunk. You can think of an embedding as a kind of semantic fingerprint. Instead of the computer working with messy words, it now works with structured numbers that represent the concepts behind the text. In this high-dimensional vector space, similar meanings are close together, and the different meanings are far apart. For example, a paragraph about how to change a car tire and a paragraph about how to replace a bicycle tire would have embeddings that are near each other because their core ideas are similar, even if they are using different words. Meanwhile, a paragraph about cooking lasagna would be much farther away. By embedding the chunks, we make it possible for our system to search by meaning rather than by keywords. This is fundamentally different from traditional keyword search. It enables semantic search, finding things that mean the same even if they are phrased differently. And finally, we store all these vectors in a vector database. A vector database is a special kind of database designed to handle high-dimensional vector searches efficiently. Instead of scanning through words, it quickly finds the closest matching vectors to a query vector. To summarize the whole flow we saw, we start with the messy source data, we extract the clean text we need, and then we chunk it into manageable, meaningful pieces. After that, we embed each chunk to create vectors that capture meaning, and then we store these vectors in a special vector database for fast retrieval. And why is all this necessary? Because without this preparation, the retrieval step in any retrieval system would be slow, inaccurate, and meaningless, especially if you want to use this retrieval system for RAG. By vectorizing our data smartly, we ensure that when the user asks a question later, we can retrieve the exact pieces of knowledge needed, and AI can generate grounded, accurate, and helpful responses. Okay, enough about the concept. Let's jump into the implementation where we can use LangFlow to create this flow to do exactly the all the steps we discussed here to create a vector database out of a PDF file. All right, it's a fun time now. I think we talked a lot about the vector database, about the embeddings, chunking, extracting, and all those kind of steps are needed for creating a vector database. Now, here's the time to test it out in a simple process. So, first thing first, we need to install the LangFlow. I have done the tutorial how to install a LangFlow, which is quite easy, but yeah, we can also do it again here, which is very simple. I'm using the uv command, and you can say install uv pipe install LangFlow. So this is the command you will use if you want to install LangFlow for the first time. And oh, I misspelled the installation. Okay, I had some issues with the pipe itself, but with UV you don't get any of those issues, and it's very straightforward. So as you can see, I don't need to install because I did it before. If you want to upgrade, you can use minus capital U, and then it does upgrade if it's in it. Let's see if there is something to upgrade for me. Yeah, apparently, yeah, there are a lot of things to upgrade. As you can see, UV is quite nice. And usually with pipes, sometimes you might get a lot of issues with the packages that might have a lot of dependency to other packages, and it might stuck in the process. But here, as you can see, the UV command works very well. So now everything is done with the UV. Now I have LangFlow. In order to run the LangFlow, you can say UV run LangFlow run. Now I think I can open the LangFlow. Nice, I have LangFlow running here. So if you haven't worked with LangFlow, I would say the environment is very straightforward. It's very easy to learn, and it's a very nice built environment. So in order to start with LangFlow, you can start clicking on a new flow, and when you click on the new flow, you get this page which shows you a lot of templates. As you can see, we have a basic prompting, vector, store rack, simple agent, and a lot more other templates are here. If I click on the basic prompting here, it already give me actually completed flow, which I can use to test the OpenAI model. The only thing I need to do here is to put my OpenAI API key, and then I'm ready to go. Let's give it a try. So I put my API key here, and in order to run this flow, you just need to click on the playground, and before that probably you can actually click on any of these run components to see if the component is working. For example, on the OpenAI API, if I click on the run, if everything is correct, it will go green, and I think this is nice because there I can see everything is working. So if I click on the playground, it opens the chatbot for me here, and then I can start chatting with the OpenAI. As you can see, it's using the GPT-4o Mini here. Okay, so I don't need to save it here. I go back to my projects because I don't need to work with the basic prompting. I can also delete my flow from here. If you go to any of your flows and click on the arrow key here, it also show you a lot of interesting things. For example, you can import or export your flow. You can also see the logs, which is quite interesting to see what kind of things you have done with your flow, and also you get a lot of important information here, especially when you are troubleshooting or debugging your flow. Okay, go back to my projects. So I want to start with the new flow, and I want to start with the blank flow. Before I start creating a flow, I want to say that there is one opportunity if you want just to watch the video and then try it yourself, is to actually import the template. I already put the template in our community, which you can go there and easily download the template. When you download the template, you can import it from here. I can go to the download, and from here I can download the template. So this is what we are gonna create today, and I would suggest you can just download the template, and from there you can easily follow the template. The only thing you need to change is the configurations based on your configurations in your computer, but at least the template easily can be set up using our actually community. The link is under the video in the description. Please have a look and try that. So I go back to the previous page, and I want to start with the blank flow. So what we want to do here, we want to create a flow in which we do the old process we discussed earlier about the vectorization, and we do the step-by-step process here to create a vector database. As you remember, inside the slide, the first step was to extract the text. So we need to have an input to get the file, and then from there we can process the text. So basically what I need to get the file here, and in order to do that I can drag a file component. With the file component I can use that file component to upload my PDF file, and from there I can process further. So basically here I can drag my file here. If I go to the documents folder, I have two PDF here. I want to use this PDF. This is the story I created recently using ChatGPT. This is quite nice story about the parrot which is exploring a castle in the middle of a jungle. So it's quite nice. So I'm gonna use this PDF as an input file for this tutorial. So I click here, go to the documents, upload my PDF. So now my PDF is uploaded successfully. As you can see, when you create a component or drag a component into the flow, you have input and output options here. I have some output options. The next step we wanted to split the text into the chunks, right? But before that we need to get the output from this document. To do that, you can search for the split here, and you can see the split text here. So basically here I can connect the file here, and as you can see here, because I already have this component already extract the text from the file, and then I can use the output to use here in order to do the splitting. So as you can see here, we have the input data or data frame. I can use the data here connected to the data frame. There are some settings here already that are configured by default. I don't need to change that, but in your side, if you want to play with the chunk overlap or chunk size, you can do that. If you do the most over on any of these properties, you can actually see what that means. For example, the chunk overlap means the number of characters to overlap between the chunks. So basically this is how I can split the text, and the next step is so when the split is done, then we need to do the embedding actually. So but now before all of this, let's give it a try. So we already uploaded the document. If I run this, it says no files to process. So I thought I did upload. Okay. Now I got the confirmation here. The file is shown here. Now what I need to do is to see the output. As you can see, you can inspect the output of each component. So the whole text is extracted from the document. Now next part is to splitting the text. If I click on this part, the splitting is already done. And if I click on the chunks, I can see that the chunks have been created from the document. This is quite nice how you can see each step separately in the flow before even creating extra step to your flow. So the next step we wanted to do was embedding. So in order to do the embedding, we can look up for the embeddings, and I want to use the Ollama embeddings, but of course you can use any embedding models. So I just drag the Ollama here, and what I need to do is to also choose a vector database here, because after the embedding we save the embeddings inside the vector database. So in order to do that, I'm gonna choose ChromaDB, ChromaDB is a really nice vector store that you can use freely, and you need also to define a local store for that. I mean the local path. So now immediately we notice the embedding here inside the ChromaDB, so we can connect this embedding to here, and here also we need to add the chunks to the ingest data. So the ChromaDB gets the ingested data, use the embedding model here, and then do the magic for the embedding, and then store everything in a vector database. But for the Ollama embeddings, when you put the Ollama embeddings here, you need to choose the model. So basically, if I go to the Ollama website, and if I go to the models, so here you can click on the embedding and you can choose one of these embedding models. I'm gonna choose the, I think, if I'm not mistaken, I already should have the nomic embed text, but let me see to just make sure. So when you are here, and if you already installed Ollama on your computer, then if I click on the refresh, you can get the list of the embedding models here. So as I said, I have nomic embed text. So for the Ollama, if I open another terminal window, so if you have already Ollama installed on your computer, of course you can get the command to use Ollama. So I can use Ollama list. So currently these are the models I pulled from the repository to my computer. Nomic embed text is the one I'm using for the embedding. So the embedding is also done here. The only thing is we need to create a folder to address it here. So I'm gonna create a new folder, probably here in the documents. It doesn't matter because it's just a test. Test, I would call it test vector DB, and that's it. I just copy the path and then paste it here. I think should be fine now. If I click on the component, run component here on the ChromaDB, then as you can see, it is busy with the embeddings. Okay, as you can see, the embedding is done in 12 seconds. So what I can do, I can go back to the folder, and as you can see inside the folder, already ChromaDB created the files it's needed for this PDF file. So the whole process is done. This is, as you can see, exactly matches with the flow we discussed earlier in the concept design. And this is how you can create a vector database inside LangFlow. So one thing is interesting is that you can also already test your vector database even without having any chatbot or anything else. And in order to do that, you can use this search query here to do the similarity search. For example, for this particular story, I know that there is a story and there is an end of a story. So I would actually ask for the end of a story to say what happened in the end of a story, but I'm just using the end of a story here. And if I click on the run component here, and then its process is done. If I click on the search result here, it shows me the similarity search actually related to the end of a story, which is quite interesting. That because I wrote a story, I know that what happened, and it's interesting that I can see that everything related to the end of a story are actually listed here. Of course, there are other information, but I can see that also the most relevant information also listed here. So this is quite nice, that how you can create a vector database and test it inside LangFlow. I would suggest to give it a try, test your process with any of the files that you have in your computer, just to see how it works. I hope you like this video, and please like and subscribe and support this channel to get more videos soon. Thank you very much.